citation. I'll be talking about bioinformatics, that is data analysis. So bioinformatics people are in need of all those data. I will also explain it in a moment, especially for doing longevity research, finding longevity interventions. And I will also talk a bit about how to use AI for this. And first, actually, usually start my talk by pointing people to the Biomarkers of Aging Consortium. This is, of course, also about large-scale data analysis, also observational data, but of course, it would be even more important to have interventional data. And this consortium is running competitions. There are some nice papers where I had the privilege to be contributing to those papers on defining what biomarkers of aging are, and I will come to that in a moment, and also on the validation of biomarkers of aging. And of course, you want to have large data sets to really have good biomarkers of aging and then to use them. And how are they used? So on the one hand, well, that's straightforward. You want to predict future health and survival. So if you have kind of better values in your biomarkers compared to other people, you hope for longer health and longer health and longer survival. And but they can also be very useful to predict suitable interventions. So if you can match your biomarker values to intervention data, and there the people with similar values actually benefited from a specific intervention, then maybe that is the intervention that is also benefiting you. Okay, but in the first part now, I'm thinking a bit about what is actually aging, and I will also talk about neuroscience. So, what is the meaning of this term? And a while ago, I actually was joined with a philosopher, Ludger Jansen, and he and me and other people from a EU consortium, we in the end define it in the following way: that health is a lack of dysfunction and disease, defined by the ICF and the ICD, with the International Classification of Function, Disability and Health, and the International Classification of Diseases. And then well-being, it's kind of about health and survival. It's a weighted sum, probably in a personalized manner. And aging as a process that reduce well-being. So we published that in 2019, and also for also Alan Cohen at that time was a big question. For example, having an accident, is that aging? And actually, I always said, yes, it is, because you want to be free of arbitrary thresholds. And of course, you can introduce thresholds later. You can define that framework. And actually, just last year, this is a slide from a talk of Alan Cohen at the Biomarkers of Aging Symposium.
Just technical. Actually, we don't see. We see your the first slide, but not more.
Yeah, there are some technical problems still. I will stop sharing and restart it. I hope it's working.
Yeah, sometimes it's working like that.
Yeah, there is some. I don't know what's going on. So I was missing the.
Yes, no, it's okay. We can see.
And maybe now it's much better. Can you now see the slides moving?
Yeah.
Okay. Sorry about that. So those were the first slides on the Biomarkers of Aging Consortium, what I talked about, and about the role of biomarkers predicting future health and survival, predicting suitable interventions. And then I talked briefly about what is health, lack of dysfunction and disease, and well-being is a sum of health and survival, and aging as a process that reduces well-being. Okay, and yeah, and I said this is a kind of question. If you have an accident in this kind of definition framework, is that aging? And actually, if you think about it, yes, it is. And the idea here is to be free of any arbitrary thresholds, because you can introduce them later and refine the framework. Many years later, actually, Alan Cohen last year at the Biomass Aging Consortium, he showed this slide, where he's indeed then saying, okay, there are many mechanisms of aging, and if something happens, there are cases where hundreds or thousands of mechanisms are in a weird way involved, but they are not universal. And this is a kind of case in an accident. Whereas for specific diseases, it's more universal, fewer number of mechanisms. And then there's everything connected with what we are most interested in aging, which is also reflected, at least in part, by the hallmarks of aging. Those are pretty universal mechanisms, but there are a few of them. So it's about understanding aging. What are the mechanisms behind it? And then, of course, how to design interventions as a next step. And in this table, I've compiled the concepts. Just let's contemplate it for a moment. There are states and there are time periods. So it's about health, survival, well-being, and what we call ill-being, and the baseline. The time periods and a health span, lifespan, well-span, ill-span, and chronological time. And then think about the process behind this. We can also name them specifically the opposite of the well-being processes. These are the aging processes. And on the one hand, you consider in philosophical terms the continuance, and on the other hand, you consider the occurrence. And going further, there are definitions of biomarkers. What is a biomarker? And it's a pretty difficult, pretty hard to say, actually. It's a very general and generic term, like anything that can be measured, but that is an indicator or that is a characteristic. But the question is, what is that, a characteristic or an indicator? And I would propose a biomarker is just a feature of the state of an individual that allows prediction of another feature of the same individual. Not necessarily at a later time, but for a biomarker of aging, it's any feature of an individual that predicts temporary later feature of something with ill-being or well-being, and does it better than chronological age. That was this now 5-year-old definition. And biological age is then, it seems, a composite biomarker that predicts future well-being in the best possible way. And then during molecular, health span pathways, or health span pathway is a set of molecular features of health that relate to each other, that belong to the same molecular setup, the same molecular pathway. And this way, I think we have a framework to think about biomarkers of aging, and we then can apply it. And yeah, I think we have got some more clarity of thought that way. So here, as this kind of table for the last time, you saw the aging processes, and then biological age as a predictor of the future state of well-being as well as ill-being. And then we define health operationally by stress resistance, strength, and cognition. And cognition goes together, but it's also two different aspects of physical function and cognitive function. So once you have a nice definition in terms of terminology, you can operationalize it. You can think whether the operationalization is actually a good one, and then you can even go through the literature. And today you could be doing that with a large language model. At that time, it was a huge exercise of checking lots of references to come up with details about this operational definition of health, and thus of aging and of biological age and so on, because as you saw, those are of course tied together. Yeah, now neuroscience, I mentioned this already, is a kind of concept also maybe now 10 years old. And the idea is we know enough about the mechanisms of aging, the biomarkers also, and the aging mechanisms, the hallmarks of aging, and the health span pathways. And we have enough ideas for interventions that may indeed work. That's the engineering idea, in contrast to the science, that we can just now develop, engineer aging science-based interventions that do work to counter disease and dysfunction. And there are a couple of reviews, also recent reviews about the geoscience hypothesis, essentially saying, okay, we know enough in science and engineering that we can indeed do something, that we can try out interventions. Of course, it's an open question, and some people actually understood geoscience entirely from the science perspective. There were some papers actually this year, David James and others, about inflated expectations in translational research on aging. And okay, they said essentially this geoscience agenda in the middle, it's kind of the result of failure of earlier theories of aging, like very simple ones based on antioxidants, oxidative stress, and so on. But also the perceived need to do something about aging. And then in this kind of vicious cycle of investors and translation researchers, financial speculators, and unaware of recent negative findings, this kind of evolved in a, what they say, in not a favorite direction, because yeah, they thought we can do something, and we should do this translational push. We should do translation, which I also believe in. But they think, no, it's not so easy to translate. The results of the translationary approaches up to now were kind of, yeah, weak and over-optimistic and so on. And they say essentially, okay, it's much easier now, right now, to understand aging than to really engineer interventions, in contrary to what most other people say. And how to find out? Essentially, of course, yeah, by trying out interventions and understanding them. And I think both things go together. You want the science and the engineering go hand in hand. And essentially, reasoning from fight aging, yeah, he more or less stressed that the engineering is successful right now. And I would say yes, with of course a lot of caveats. But I would also say that if you criticize this neuroscience research as just engineering of or science of very of just tinkering with metabolism of those interventions that are not probably not giving a lot of returns, I think you are wrong. I think it's also about senolytics, also about partial reprogramming and other aspects of longevity interventions. And here I believe if you get it right, you can have quite some effects. Thus, I think it's not this baby and bathwater argument, because neuroscience, I think, at least in a wider sense, is really also engineering in many ways. It's not just about but it is about going under. It's about understanding, about really trying to have a scientific approach as much as possible. So understanding engineering, and this is now coming back to the data, this is essentially for me also a role of bioinformatics. We've got those neuroscience interventions on the left, medication, lifestyle, and so on. And we want to understand them, especially in human, and there we need to consider, of course, the context, all those confounders, and the data analysis. I think this is not getting much better, or it will soon get much better, because there's not just the classical approaches, but also lots of approaches based on using large language models and knowledge graphs. And I also hope that there are more and more good data, because this is essentially where I perceive the problem or many problems. We need more data. We need more good methods. This is my main slide here. I think, but if you consider it, almost no aging plots are actually trained on intervention data. They are trained on observational data. And so imagine in toxicity research, a liver toxicity predictor is just trained on young and old livers. It sounds almost ridiculous. And of course, the reason for not training intervention data is that there are so few intervention data. And that's now connecting to the main theme of this meeting. Yeah, we need much more data, especially human data, for training and benchmarking. And I actually found only two examples, two very recent ones, of intervention-based learning of what I would say are really good aging plots then. That's a paper by Rajab Sehgal. It just recently came out on epigenetics data, actually. They collected 51 longevity intervention studies in human. Another paper, also very recent, by last authors Pedro Mayoras and Alex Freitas, where they used, and they said for the first time, intervention data to learn new interventions, whether chemical compounds could be life-extending or not. And I would give a bounty for other hints, because I'm really desperately looking for more examples. Maybe I'm missing all of them that are there, but I didn't find them also. I did not find them in the references of those papers either. Yes, and this point was also made by Dmitry Kirkov in this paper in Aging Cell. And they also said, okay, we must consider uncertainty. There's almost no consideration of uncertainty in this work on aging clocks and other predictors. So, and I would suggest actually to look into conformal prediction. That's a side issue, and I can explain it in the questions and answers if you like. And there's also another problem is there's almost no consideration of automated machine learning. And I believe that we must explore the AI and machine learning method space much more extensively. It's not just elastic nets or some other, okay, there are also some other deep learning methods for aging clocks, but it's mostly actually based on elastic nets. And here I'm working on this with Daniel Palmer and Anton Kulage and others. And there are far too few considerations of confounders. Like you want to use tools like combat, differential express genes, fantastic PCA, and there are also not enough. There's not enough systematic consideration of side effects. This is important, I think, side effects, and this is, I would give an example how to extract understandable linear features, actually as a first step, and then learn classifiers or other predictors. And that also takes care of the confounders to some degree, of the side effects, and of interpretability or understandability. So this is just one slide on ongoing work together with Daniel Palmer and Roberto Avila. We actually have ministry-funded academic project running that could end in the startup for intervention analytics as a business-to-business model. And here you see a contrastive PCA plot. Contrastive PCA is not very well known, but it looks like to be very appropriate to delete some confounding issues. And you see on top metformin and blueberry, those interventions are not in similarity space. It's similar to principal components, and they're very close together. The pie charts indicate what kind of biological processes, like similar to hallmarks of aging, are actually going on if people take metformin or blueberry apple juice. And on the other hand, on the bottom of the PCA, you see partial reprogramming data, and you see that there are other processes highlighted, which actually made a lot of sense. It's DNA proliferation, stress, and such. So we believe we are developing methods now to really understand longevity interventions, combining science and engineering. Yeah, and there are a few more slides. One that is close to my heart is longevity study designs. And I presented that at the AARD conference. And it was kind of the idea, what can large language models do to design longevity studies? And this was after some dialogue, those are some designs by AI, by generative AI, the dietary intervention study, physical activity study, and the pharmacology intervention study. They're rather boring, but that's to be expected because, of course, those large language models in their training data, they find lots of such information related to those kinds of studies. Pretty boring still, but you can nudge those models into coming up with more exciting, but of course also more risky interventions. This is a study that will probably not be easily accepted by an ethics commission because it's essentially about epigenetic modifications by some cancer-related drugs. So drugs used, for example, against cancer, which are inhibiting epigenetic enzymes. That's actually the first arm. The second arm is about mimicking the effect of reprogramming factors, which is quite similar. The third one is about epigenetic interventions and NAD precursors as a combination. If you ask a model why this combination, you actually get a good hint for a paper where NAD and reprogramming are mentioned together. But what I'm proposing is to have a leaderboard to find the ultimate longevity study designs, because it's pretty expensive to do such studies. We are not looking at large signals, so you want to design them well. We also did the same on health and productivity. So not just going for longevity interventions, but also for being productive along the day. And there actually, there was some nice ideas by the large language model. For example, taking people at risk of cognitive decline, and then, for example, suggesting fish oil, or also low dose lithium, which in a very low dose is essentially pretty well substantiated. If you look at epidemiological data, the more lithium in the water, the public water supply, the better people seem to be in their health and mortality. And yeah, this is essentially the final, almost the final slide. Not sure. I think I also, yes, I'm running out of time in a moment. So this is a very recent paper on large language models and their diagnostic capacities. Essentially, in this trial, they were better than the doctors and better than the doctors who were guided by AI in some diagnostic exercise. And this is happening more and more frequently, and it's of course causing lots of ethical and other considerations in medicine. So I'm working also together with Anton Kolaga on thinking about what are good responses by models, how can one evaluate them, those validation requirements. I won't present them here because I think I presented them already in February to a similar audience. And finally, this is our agenda at the IBIMA. It's a Rostock Institute for Biostatistics and Informatics in Medicine and Aging Research. We did 3 neuroscience trials, essentially neuroscience that we looked for xenotherapeutic in animals. We did an observational human trial, and we did a nutritional strawberry study, where we actually saw some hints for apoptosis, potentially of senescent cells by a kind of radical Mediterranean diet that was at least radical on a few specific days. And there are specific projects ongoing, as I said, on health and productivity, also on AI and neuroscience, advised by large language models, and also on toxicology and neuroscience. And with that, I would like to say, stay healthy. I welcome you to Rostock, hopefully in April and October next year for events regarding Rostock Longevity Days. And apologize, I did somehow technically it didn't work all well. I'm also missing the mouse. I could not use it as a pointer, unfortunately. But I hope I was able to get most of my ideas across. And I'm thanking all the people, my efforts and the group's efforts, and I'm thanking all team members.